Very good morning to all. Today our research topic is aluminum 6082 boron carbide composite materials preparation and investigate mechanical and electrical properties with CNC turning. First, we will go to overall view of the presentation. Aim, objectives, matrix material, reinforcement, experimental testing, experiment and testing, testing results and conclusion. Aim. In production world, the alloys are most preferred than monolithic material. The various alloys, calcium, magnesium, chromium, silicon, and aluminum are applicable in all type of industries. The aluminum 6082 alloy is more preferred than any other alloys due to less weight, high strength to weight ratio, and less cost. In this article, aluminum 6082 alloy is mixed with boron carbide reinforced material by mechanical stirring method. The specimen is tested by hardness and tensile test. The some analysis is made and calculate the grain particle distribution. This casting is machined in CNC machines. The machining parameters, speed, all type of inserts are studied. These machinability studies are compared composite materials. Next one is objectives. The significant objectives of research work in this paper is to synthesize the aluminum metal matrix composites with boron carbide reinforcement particles in different volume fractions through a liquid metallurgy process, to inspect the microstructural representation of aluminum metal matrix composites by using SEM, scanning electrons microscope, to evaluate the mechanical properties of hardness and tensile properties, to analyze machining characteristics of the aluminum metal matrix composites by using CNC machine by varying machine parameters, speed, feed, and depth of cut of the composites. Next one is metal matrix composites. There are two phases, primary phases and secondary phase. Primary phase, it forms the matrix within this. The secondary phase is embedded. The primary phase is the aluminum 6082. It is the starting space, and the secondary space is embedded phase, sometimes referred to as a reinforcement material added agent. Here, reinforcement material is boron carbide. Matrix material, aluminum alloy 6082 is a medium strength alloy with excellent corrosion resistance. It has the highest strength of 6000 series. Alloy 6082 is known as structural alloy. Aluminum alloy 6082 is the alloy most commonly used for machining. As a relatively new alloy, the higher strength of aluminum alloy 6082 has seen it replace 6061 in many applications. The addition of large amount of manganese controls in grain structure, which turns results in a stronger alloy. This is the aluminum 6082 chemical composition. And there is an silicon 0.7 to 1.3 percentage, ferrous 0.0 to 0.5 percentage, copper 0.0 to 0.1 percentage, manganese 0.4 to 1 percentage, magnesium 0.6 to 1.2, etc., up to remaining chromium 0.0 to 0.25 percentage. Remaining is aluminum, and this is the aluminum 6082 chemical compositions. Next one is boron carbide. Boron carbide B4C is the one of the hardest material, we are all known, ranking third behind diamond and cubic boron nitride. Boron carbide is characterized by its extreme hardness, difficult to sinter to high relative densities without the use of sintering aids, good chemical resistance, good nuclear properties, low density. Boron carbide properties, there is the properties density 2.52 gram per centimeter cubed, and melting point is 2445 degrees Celsius. Hardness 2900 to 3580. Fracture toughness 2.9 to 3.7. Young's modulus 450 to 470 gigapascal. Electrical conductivity 140 degree Celsius. Thermal conductivity 30 to 42 Weber per meter Kelvin. Thermal expansion coefficient 5 degrees Celsius. And thermal neutron capture cross section 600 bond. These are the boron carbide properties. There is an experimentation to fabricate the composites. Predetermined quantities of boron carbide considered as per the sample composition given below. There's an aluminum 6082 100%. This is the monolithic material. Next one is aluminum 6082 plus boron carbide. 94% of aluminum 6082 and 6% of boron carbide. Next one is 92% of aluminum 6082 and 8% of boron carbide. Stuck casting. This is the initial method. The stuck casting readings are noted in the table below. The monolithic aluminum material and aluminum with 0.94 and boron carbide 0.06 ratio, and aluminum with 0.92 and boron carbide with 0.08 are the various weight ratios noted. This aluminum 6082 material is mixed with boron carbide. Various fraction of boron carbide is mixed. The furnace temperature is noted in the table also. The preheated temperature and setting time and stir spindle speed are noted in the table below. There is a material one aluminum 6082 plus boron carbide 0.94, 0.92. These are the various fractions added. Aluminum 6082 plus boron carbide. The temperature furnace is noted 794, 797, 7802 up to. These are the table indicates the die preheat, boron carbide preheat, stir spindle speed, time, setting time, and the percentage of material composition are noted. Next one is sample image. This is the aluminum 6082 plus 6% of boron carbide, and is aluminum 6082 plus 8% of boron carbide. These are the various two sample images are available. The various investigation carried out on fabricated composites and their scan electron microscope, tensile test, hardness test, miscibility, and surface roughness are calculated. These are the same images. Aluminum 6082 6 weight percentage of boron carbide, 8 weight percentage of boron carbide. These are the two same images. There's some images of aluminum 6082 alloy with 6% boron carbide and 8% boron carbide. The boron carbide particles are evenly distributed in some images. The stuck casting method is more suited in the boron carbide reinforced materials. The aluminum alloy mixed with boron carbide is high risk due to low welding ability and small agglomeration. These factors produce non-uniform distribution, poor mechanical properties. And some images indicates the primary alpha aluminum dendrites and eudenic silicon with boron carbide particles are separated at interdendritic regions. The studying of before and after introducing of reinforced particles results in breaking of dendrite-shaped structure into equiaxial form. The same photograph indicates gradual distribution of reinforced material, and boron carbide has more number of grains. These grains are equally distributed with 8% of aluminum 6082 alloy. These are the same images noted. Next one is tensile test. Next tensile test was carried out on universal tensile testing machine. The test samples were prepared according to ASTM standard E0808. The obtained tensile test results were shown in the below table. Aluminum 6082. The yield stress is 106.56. Ultimate tensile stress is 121.68. And next one is aluminum 6082 plus 6 weight percentage of boron carbide 118.32, 156.20. Next one is aluminum 6082 plus 8 weight percentage of boron carbide 132.40, 174.90. These are the ultimate tensile strength. Where is noted. Next one is hardness test. And the workpiece is cut from the casting alloy with record dimensions of 40-30. The specimen is polished under emery sheet. The polished samples are admitted into Rockwell hardness testing machine. The diamond indented with load of 100 kg is applied. The three average readings are taken. The boron carbide is added 6% and weight percentage 8% weight ratio. The hardness values are noted in the below table. The boron carbide values are increased. The hardness values are increased. The below table indicates the hardness value for aluminum 6082 monolithic material 6% and 8% of boron carbide. The hardness value is increased from monolithic aluminum with aluminum alloy with 6% and 8% boron carbide material. As the reinforced particle is increased, the hardness value is also increased. These are the main noted point. These are the table, Rockwell hardness test table, and there is the load 110 kgf is given, and there are three various specimens: aluminum 6082 and aluminum 6082 plus 6% boron carbide. Next, aluminum 6082 plus 8% boron carbide. The tensile values T1, T2, T3 are noted. The average hardness values are increased from 38.66 to 43.66. When the boron carbide is percentage of boron carbide percentage added is increased, automatically average hardness values are increased. Next one is machinability. Machinability means the removal of material from parent material with high finish and low cost. Good machinability required less power to cut and less tool wear. The machining parameters are feed rate, depth of cut, and cutting speed. The machinability depends the machining parameters. There are three passes are created. The various parameters such as cutting speed, feed rate, the machining parameters are feed rate, depth of cut, cutting speed. The machinability depends the machining parameters. There are three passes are created. The various parameters such as cutting speed, feed rate, depth of cut, machinability rate, metal removal rate are noted. The cutting speeds 1600 to 2200, 2500 RPM are noted. For this various parameters, the machinability rate, metal removal rate are noted. As the reinforcement material is increased, the machinability rate and metal removal rate are also increased. The figure shows the aluminum 6082 monolithic alloy after CNC turning. These are the images after turning. Aluminum 6082 alloy, aluminum 6082 plus 6% boron carbide, aluminum 6082 plus 8% boron carbide. There are the various machining parameters. Aluminum 6082 alloy, cutting speed is increased. 1600. These are the constant value 1600 RPM. Feed rate 0.2 millimeter per minute. Depth of cut 2.5 millimeter. And machinability rate there is 3.5 to 4.1. Metal removal rate 154.25 to 178.89. So machinability rate and metal removal rate is gradually increased at the constant cutting speed and the feed rate and depth of cut. This is the machining parameter with another set of experiment. Cutting speed, various parameters, another cutting speed 2200 RPM and the feed rate 0.3 and depth of cut 3.2. Machining rate is 3.9 to 4.9. Metal removal rate also increased 182.4 to 204.8. This is the another set of parameters. Cutting speed is increased 2500 RPM and the feed rate 0.5 and depth of cut is 2 millimeter. The machinability rate 5.1 to 6.7 millimeter per minute. Metal removal rate is increased 2.5.4 to 32.4. And these are the various set of parameters. Automatically machinability rate and metal removal rate are increased. Next one is surface roughness. The specimen are prepared by emery sheet and minted into surface roughness test. The surface roughness values are noted. These values are increased from monolithic aluminum 6082 alloy to aluminum 6082 alloy plus 6% and 8% boron carbide added. As reinforcement material is increased, the surface roughness values are increased gradually. The surface roughness test machine is shown in the figure. Finally, we have some conclusions. Yeah, aluminum 6082 alloy combined with 6 percentage weight percentage of boron carbide and 8 weight percentage of boron carbide materials. The hardness values are increased from monolithic material to aluminum 6082 plus boron carbide material. Better to going to previous slide. These are the very good example. There is a constant load, 110 kg. This specimen, same specimen, aluminum 6082. Next one is aluminum 6082 plus 6% of boron carbide. Next one is aluminum 6082 plus 8% of boron carbide. The average hardness values are increased 38.66 to 43.66. So mixing of the reinforcement material, boron carbide plus monolithic material, aluminum. This composite material, aluminum 6082 plus 8% of boron carbide. These third row. And these composite material is better hardness values. Better hardness values. It is the first conclusion point. Next one is whenever the hardness value is increased, automatically the tensile values are increased from monolithic material to composite material alloy. Better. We are all going to tensile test. These are the same three specimens: aluminum monolithic material, aluminum 6082. Here, aluminum 6082 plus 6 weight percentage of boron carbide, aluminum 6082 plus 8 weight percentage of boron carbide. These are the common. Automatically, the ultimate tensile values is increased from 121.68 megapascal into 174.90 megapascal. Automatically, the ultimate tensile strength values are increased. These are the second conclusion point. Next one is the SEM analysis. The SEM analysis was conducted for monolithic the SEM analysis was conducted for monolithic and boron carbide material. The boron carbide materials are evenly distributed in that alloy. There is 8% weight ratio of the boron carbide plus aluminum composite material. The boron carbide materials are evenly distributed in that alloy. Better we see the diagram, SEM analysis diagram. These are the 6082 plus 8% of boron carbide evenly distributed. And these are the better specimen and better composite material, aluminum 6082 plus 8% of boron carbide. These are the final conclusion point in this SEM images. Next one, the machining characteristics are studied. The various parameters such as speed, feed, and depth of cut are noted. The machinability rate and metal removal rate are increased from monolithic material to composite material. These are the set one. Machinability rate is also increased from aluminum 608 to aluminum 602 plus 8% of boron carbide, 3.5 to 4.1 millimeter per minute. Metal removal rate also increased 154.25 millimeter per minute to 178.89 millimeter per minute. And also, getting speed and feed rate is increased. Machinability rate is also increased 3.9 to 4.9 and metal removal rate from 82.4 to 204.8 millimeter per minute. Next also the another set machinability rate is increased from 5.1 to 6.7 millimeter per minute. Metal removal rate 205.4 to 232.4 millimeter per minute. These are the various metal miscibility rate. The metal removal rate also increased. We know also already increased. These are the final conclusions. Final conclusion says, compared to monolithic material, this composite material, especially boron carbide composite material, is more hardness value, more tensile value, very good semi images, evenly distributed semi images, and very good miscibility rate under such parameters. Feed rate and miscibility rate are also improved. So these aluminum 6082 plus 8% of boron carbide material composite alloy is more better material compared to monolithic material. This is applicable in all type of industries, especially such kind of armed forces industries. These are the main applications. So we concluded that aluminum 6082 plus 8% boron carbide composite materials material is very better material, better composite material. These are the final references we have noted. Thank you. Thank you very much. Thank you very much, sir.